Hello. In the part 4 today, we shall discuss single push-pull inverter by two MOSFETs directly driven by PWM IC, that is TL494. So before we go into all those details, let's try to understand the circuit first. In the circuit configuration here, we have the as usual the PWM IC TL494. This has two outputs. In fact, there are two transistors inside. This is the collector and this is the emitter of that. And this is the collector, this is the emitter of that. And the emitters are all grounded and collectors are pulled up to positive voltage. We can verify that with C1 and U1, that is collector 1 and emitter 1 of this output. And for this output, collector 2 and emitter 2. This is the block diagram that we are watching for the TL494. And RTCT, as we discussed, is required for the frequency. And this is the dead time control, which we have discussed, and today also we'll discuss about them. And there are two error amplifiers for the purpose of certain other activities, which we will cover at a later date. And there is a regulator which gives a fixed voltage of about 5 volts and with the input of about 12 volts or 15 volts, whatever it is, in the VCC, and this is the ground. This is the block diagram of that. So this is that collector 1 and emitter 1. Emitter 1 and emitter 2 are grounded, and collector 1 and collector 2 are pulled up by some resistor, and then it goes to drive the MOSFET directly. And the arrangement what we have made here, we have actually during the high, when this goes high, the current flows through this resistor and then makes this high. In the process, this conducts. And similarly, when at that time this is low, so naturally this doesn't conduct. And next positive, so this becomes positive, and so this conducts. And at that time this is negative, this doesn't conduct. So this is how the conduction takes place for 10 milliseconds here and 10 milliseconds here. That is for a 50 hertz supply, which is 20 milliseconds in total. Now, the arrangement which has been done here with a diode is because, you see, while it charges the capacitor, but the discharge path also has to follow through this resistor. In the process, there will be some amount of delay. To avoid that, what we do, we provide a diode here so that the discharge will take place by this, because by the time the collector would have gone to ground. So first it goes high and then it goes to ground. So this discharge takes place to this diode. Similarly happens with this. And then the R and C, as you can see, is selected here. C is this one, R is 0 for the selecting the frequency. Error amplifiers we are not using, that is why we have just given some connections here as per the requirement. This is the dead time control. The dead time control, we have made some arrangements here. What we will find that how the dead time control is affecting the operation or the function of the inverter. So what happens when this is on, the first current flows from here through this winding and then goes here, conducts here. So this half of the winding, the current is flowing. That time there is no current flowing here. But then when this switches off, apart from the charge being taken away, that's a different point. But then when this switches on, so what happens? The current again starts from here, flows through this, and then completes the circuit. That is how it goes this way and then this way. And in the process, the output will be this way and this way. In the process, it becomes AC. So that's what we have been watching here. What is happening? You see, the AC load is switched on, and we have given some numbers here in order to easily identify the pin connections. We have given some number here 9 and 10. This 9 is connected actually here, this 10 is connected here. In order to avoid the complications looking circuit, so we have done like this. Now what you see, this 9 and 10 is the output which is coming from the TL494, 9 and 10. This collector 1 and collector 2. And the output we have taken from a transformer. You can see the output here. This is the beauty of the waveform, that there's a difference here also. If we zoom it, we can see it little better. You see what happens. There is a dead band between the on and off time. The dead band, and that is how you don't find any spikes in the That is, at a time, none of them are possible to be switched on. So that is why you don't find any spikes here. So they can come back to this. What we find is this is the kind of waveform that we get at the output. Now look at this. When we change the dead time here, like for example, I come here, you see this becomes a little narrow. And when I go here, it is widening, getting widened. So the dead time is increasing here. Based on your requirement, in fact, this kind of waveform can be with filter, can be made to a sine wave also. That is the beauty of this kind of function. Thank you.